Hello everyone, I am Vishnuprasad H. My student code is PCM 24455. I am currently pursuing Masters in Construction Engineering and Management program in CEPT University. This portfolio demonstrates the feasibility study on the Greenfield Expressway project as part of Construction Project Formulation and Appraisal Studio. The study employs CPO analysis, location and demand analysis, stakeholder management, project baseline, and procurement strategies. This feasibility study examines alignment, structural design, traffic forecast, ecological and social impacts, cost, toll revenue, and financial viability, and ensuring the project's success. The name of the project is Construction of 6-lane access control Greenfield Expressway from kilometer 0 to kilometer 213.803 in two packages connecting Tharad to Ahmedabad under the scheme of Bharatmala Pariyojana in the state of Gujarat. The length of the project is 213 kilometers and 803 meters. The estimated project cost is 13,567.25 crores Indian rupees. The construction period is estimated to be 2.5 years and the operation and maintenance period is proposed for 20 years. The project proposed to be on HAM model under two packages. Package 1 from Tara to Mehsana with a length of 105 km and 800 meters and package 2 from Mehsana to Ahmedabad with a length of 103 km and 3 meters. The scope of work includes 13 interchanges, 20 flyovers, 8 railover bridges, 85 major and minor bridges, 203 underpasses, 684 culverts, 8 wayside amenities, 2 parkings, and 11 toll plazas. Coming to the location analysis, the project being located in the state of Gujarat passes through the districts of Banaskantha, Patan, Mehsana, Gandhinagar, and Ahmedabad, and having a total distance of 213.803 km. The proposed expressway connects the missing link between the Delhi-Mumbai Industrial Corridor and Amritsar-Jamnagar Expressway. This connectivity boosts the economic growth between the 5 states such as Gujarat, Maharashtra, Rajasthan, Punjab, and Haryana. The existing routes are SH7, SH41, SH54. The macro factors assessed were distance, project cost, economic hub, social assessment, and population growth, while the micro factors were flyovers, interchanges, railover bridge, existing structure, rivers, canals, and streams. The Ahmedabad is selected as a connected node which is flourished with textiles, logistics hub, education sector, health sector, pharmaceuticals, etc. While the Tharad is strategically positioned as a key junction connecting the smaller towns and rural areas to urban centers. For the selection of alignment, 3 options were selected, 3 of them starting from Tharad and ending at Ahmedabad through different alignments. The parameters such as route characteristics, land characteristics, environmental impact, socio-economic impacts, and cost were considered for the rating of 3 options. From the rating, the option 1 is rated highest overall due to its shorter route, which results in the lowest travel time. While all alignments share the same design speed, option 1 also connects more economic hubs, giving it an advantage. However, option 2 is rated highest for having the least number of structures. Option 2 and 3 have fewer economic hub connections compared to option 1, lowering their overall ratings. In the stakeholder management, there are a total of 69 stakeholders identified. Based on the typology, they are classified into 5 categories as central government, state government, local government, public-private bodies, and consultants. From the power interest matrix, it is analyzed that the local government, state government, public entities, and consultants should be managed closely since they are having more power and interest towards the project. From the power influence matrix, it is analyzed that the government bodies and consultants are the major stakeholders which needed to be closely managed. The number of stakeholders needed to be kept informed is less, such as gram panchayats and industries getting affected. From the analysis of influence impact metrics, it is identified that the state government and local government bodies should be monitored. Stakeholders like public and users needed to be kept satisfied. The landowners, political parties and media should be managed closely as they have high influence and can create impact. In the financial analysis, the detailed financial model comprising of detailed inflow, outflow and cash flow statements were projected for the contract models like BOAT and HAM, and these financial models are compared. The inflows will be similar to both the contract models, while the outflows are entirely different due to the difference in payment schedules and equity sourcing. In the inflow, the majority source of revenue is from toll collection, which is 99.37%. The other source of revenue is from the rent revenue from the land lease of amenities, which is very minor, less than 1% of total revenue. In the HAM model, the outflow includes the 60% of construction costs as annuity payment, since client only needs to bear 40% during construction. While in both, the entire money for construction is bared by concessionaire at the time of construction, which leads to sourcing of fund from debt, which is a burden in case the expected traffic flow is not generated. Also, in HAM model, there is flexibility in payment for operation and maintenance, such as the percentage payment will repeat from lower to higher every 5 years based on the relaying of payment surface. From the cash flow statement of HAM model, it is evident that the client will be having positive cash flow immediately after the commercial operation date from the financial year of 2028-2029. While in the cash flow statement of both model, we can see that the cash flow is negative for the first 10 years. Only after 10 years from commercial operational date, that is from financial year 2038 to 2039, it is expected to be positive cash flow. The sensitivity analysis for both HAM and BOAT models with scenarios of 15% increase and 15% decrease in traffic flow, which affects the toll collection, is done, and an IRR of 2.03% is generated for base case of HAM model, while all the scenarios of BOAT model are negative. The comparative financial analysis suggests that the HAM model, particularly with the aspects of potential increase in toll rates and flexibility of annuity payment, more beneficial payment scheme with respect to the client, offers a more favorable financial outlook compared to the BOAT model. It will be beneficial to both the client and concessionary. For the bid process management, firstly, the SWOT analysis comprising strength, weakness, opportunity, and threat were identified. The strengths are the client is a skilled organization having good financial support by government with experience in public-private project framework and having regulatory support. The weaknesses are land acquisition delay, bureaucratic hurdles, quality controlling, cost overruns of project, and public protests. The opportunities are traffic growth, public-private project expansion, green initiatives, and providing job opportunities. The threats are political instability, legal disputes, economic slowdown, and contracting risks. For the project, the client only needs to procure 5 consulting bodies such as feasibility consultant, independent engineer, concessionaire, safety engineer, dispute resolution board. For the procurement of independent engineer, the type of tender will be open tender with two-stage bid with quality cost based selection system comprising of 80% weightage for quality and 20% weightage for cost. The presentation of appreciation report and financial bid is valued for the selection. For the procurement of safety engineer, The type of tender will be open tender with two-stage bid with quality cost-based selection system comprising of 80% weightage for quality and 20% weightage for cost. The presentation of appreciation report and financial bid is valued for the selection of safety engineer also. The procurement of dispute resolution board is needed to address the arbitration related to design, execution or compliance with the concession agreement. The dispute resolution board will be consisting of 3 members, in which first member will be selected by the client, the second member will be selected by the concessionaire, the third member is the chairperson of the board, which is mutually selected by both client and concessionaire. The selection of feasibility consultant is based on an open tender with bid amount as 2% of project cost. The stage of bid submission is two-stage with quality cost-based selection comprising 75% of quality and 25% of cost. The technical bid evaluation criteria includes assessing of key personnel available, financial capacity, educational qualification of staff, and experience of staff. The bid process of feasibility consultant is scheduled as 70 days for bid submission and 112 days for award of contract. The contract between the client and concessionaire will be on hybrid annuity model under public-private partnership. According to the contract agreement, the partnership of client will be 40% and concessionaire will be 60% of the cost of construction. The type of tender will be open tender. The bidding system is proposed to be on single stage with 2 envelopes to reduce the time process of bidding. In 2 envelopes, technical and financial criteria can be evaluated along with the small amount of time for the bid process in single stage. The method of selection is proposed to be least cost based selection to achieve lowest cost of construction, while quality is achieved by technical evaluation. The project is divided into 2 packages, each of around 100 km length. The bidding for concessionaire will happen for both the packages. The 2-package strategy is proposed to avoid the competition from small-scale contractors since it is needed highly technical expertise. If it is divided into more packages of lesser lengths, smaller contractors will also be eligible for the bidding. The scope of work for concessionaire includes design, construction, operation and maintenance. The designer will be procured by the concessionaire only. The independent engineer and safety engineer ensures the proof checking. The cost of bidding is proposed by analyzing similar projects. The tender fee is 0.001% of the civil cost of construction. Bid security of 1% of civil cost should be deposited for participating in the bid. The performance security amount is decided as 5% of the civil cost of construction. The technical bid evaluation criteria includes assessing of key personnel available, tools and equipments contractor have, financial capacity of contractor, experience in construction, experience in operation and maintenance of similar projects. The payment structure in HAM model comprises of 40% payment by client in 4% by 10 payment structure during construction. The rest of 60% payment by client is released after commercial operation date as 40 annuities of 1.5%. The O&M payment for the first year will be 0. From the second year onwards, it will rises from 0.40% to 2.40% at the 6th year at the milestone of relaying of payment, and this pattern is repeated every 5 years. The bid schedule is proposed with bid due of 7 weeks from the date of notice inviting tender. Evaluation of tender will happen within 4 weeks after bid submission. Contract agreement should be signed within 45 days of letter of award and the validity of bid is 120 days. The bid evaluation process for concessionaire involves opening and reviewing technical bids to ensure compliance with RFP requirements, such as submitting bid security and power of attorney and verifying the bidder's experience and financial capacity. Financial bid of technical technically qualified bidders is opened and work is awarded to the lowest bidder. Coming to the conclusion of the project, we can discuss the key learnings and outcomes of the assignments. In the location analysis, assess the factors like distance, economic hubs, structures and routes, and rated using a weighted scoring table. From the scoring table, option 1 is rated highest overall due to its shorter route, which results in the lowest travel time and have lower civil cost. Option 1 also connects more economic hubs, giving it an advantage. Option 2 is having the least number of structures, but option 1 have lower land acquisition cost compared to the other alignment options. In the stakeholder management, identified 69 stakeholders. Creating matrices, identified 21 stakeholders to inform, 6 to be satisfied, 4 to be monitored, 36 to be managed closely. Key stakeholders like government bodies and consultants needed to be closely managed. Landowners, political parties and media require monitoring due to their high influence. The public and road users needed to be kept satisfied. The logistic companies, industries needed to be kept informed. The financial analysis comprising of detailed inflow, outflow and cash flow statements were projected based on the toll collection from forecasted traffic data and land lease revenue of amenities. The operation and maintenance period outflow will repeat after every 5 years based on the relaying of payment surface. Comparing the cash flow statements of both HAM and BOAT models, the HAM model have a more beneficial payment scheme with respect to the client. Also, the HAM model have a most positive cash flow statement for both the HAM and BOAT models, which is more favorable for both client and concessionaire. For the bid process management, the project is proposed to be in HAM model under public-private partnership. In the proposed contract model, client needs to procure feasibility consultant, independent engineer, safety engineer, concessionaire, and dispute resolution board. Since the client is having the design brief of having designed by concessionaire in the scope, the concessionaire itself will procure the designer. In the assignment, drafted bid cost, schedule, evaluation criteria. The strategy with HAM under public-private partnership benefiting both client and concessionaire by minimizing financial risk and other risk is suitable for the project success. Thank you.